Good day, my name is Zinhle from the University of the Free State. I am a master's student and I'll be giving a talk on computational calculations of tris-pyridine nickel molecules using density functional theory. Polypyridine complexes are molecules in which a metal core is covalently bonded to a polypyridine, such as bipyridine or phenanthroline, which the structures are drawn below. Such polypyridine complexes have been frequently used as metal challenging ligands due to their great thermal and redox stability, and also the simplicity of functionalization. Knowledge of the nickel 2 and 3 of the redox potential and electronic structures is necessary. For the DFT method, Gaussian 16 was used with the Baker 3-parameter exchange functional. Base sets used with the triple Z base sets for the lighter atoms such as carbon, hydrogen, and oxygen, and the Karlsruhe valence triple zeta with two sets of polymerization basis set for both the core and the valence electron of nickel. All calculations were done in the gas phase. The high performance computing content is 2 nodes requested with 16 to 32 cores per node and 4,200 megabytes memory per node. The runtime of the job was 30 to 60 hours for the geometry optimization and frequency calculation. Output log file size was about 60 to 120 megabytes and the check file was 1 to 3 gigabytes. The DFT results for nickel 2, we found that the optimized structure for nickel 2 is octahedral with nickel to nitrogen bond lengths all equal. The D8 species structure having two half-filled orbitals on the EG set. As seen on the molecular orbital, both the HOMO and the HOMO- are mostly on the nickel with some anti-bonding to nitrogen p orbital. The LUMO is mainly on one of the bipyridine ligands. The DFT results for the nickel 3, we found that nickel 3 complexes with 7d electrons are also 6 coordinated. But due to the one unpaired electron in the EG orbital set, the complexes exhibit Jahn Teller distortion, where the nickel to the nitrogen bond lengths on the z-axis are elongated. The lowest unoccupied molecular orbital is mainly on the dx squared minus y squared axis. In summary, the optimized geometry for the lowest energy state for Q is equal to 2 is octahedral, while geometry of Q is equal to 3 exhibits Jahn Teller distortion in agreement with experimental ESR studies on the ground state and solid state crystal structures on the geometry. DFT also showed that the reduced molecules with Q is equal to 1, 0, and -1 all contain a nickel 2 central ion ferromagnetically coupled to 1, 2, or 3 bipyridine radicals respectively. Thank you for listening to my presentation.